Hello guys, my name is Vinay Balaji and welcome to another professional prep video. In today's professional prep video, we will be talking about an important topic in calculus, also known as implicit differentiation. Implicit differentiation is very common in calculus, so it's really important that you learn this really well. So today I'm going to be going over two examples and the general scheme of how to solve implicit differentiation problems. So before I begin with the problems, I'd like to discuss the steps of how to do implicit differentiation. The first step, differentiate both sides with respect to x. When you differentiate a y term, multiply it by dy dx. And then the second is just solve for dy dx. And there you go. So I'm going to be going over a simple example and then a harder example. So the simple example is going to be x squared plus y, squared equals 31. First step, differentiate both sides with respect to x. 2x plus 2y, and remember, multiply by dy dx. Whenever you differentiate a y term. And then 31 is a constant, so our derivative would be equal to 0. After that, solve for dy dx, right? So subtract 2x. So then you get 2y dy dx equals negative 2x. I'm going to continue over here. After that, you divide by 2y. So you get dy dx equals negative 2x over 2y. And the 2's cancel out. So therefore, it's going to be equal to negative x over y for dy dx, which is your solution. Alright. Some common errors that some people might face is they forget to multiply by dy dx, and then they're like, oh, what do I solve for at the end? Or make really silly derivative, taking the derivative rules. Example, they forget that the derivative of 31 is 0, and sometimes they just straight up put 31 right here. Just remember not to do that, and you should be good to go. Now, we're gonna do a harder problem, so you guys can understand it even better than how you probably do right now. Alright, I'm just going to erase everything real quickly. Oh. I don't want to clear the page, do I? Alright. Eraser. Alright, cool. Alright, now let's talk about the second problem, alright? So, I'm going to write the problem right now, and then we can just work on it, alright? So, negative xy cubed minus x equals 4y plus 4. Alright, first thing we do is going to be negative 1y cubed. Then, because remember, one thing I would do is just underline all our y terms for difficult problems. Just to avoid silly errors, so you know which ones you have to have dy dx on. Since it's the negative xy to the cubed, you have to have it like this, negative 1y cubed plus, and then you can have a bracket or whatever you want. You take the derivative of y cubed, so 3y, remember dy dx, and then you multiply by negative x. This is how you do differentiate negative x, y. Anytime it's like xy or negative xy, anything like that, let me write it. Yeah, actually, no, it's fine. Anytime you do xy or negative xy, just remember to follow that sort of a scheme, okay? You can use this for example. I highly recommend you guys write this down so you guys can understand it in future problems you might do. And then we continue. The derivative of negative x is negative 1. And then 4y, oh, this is a 4y cubed, my apologies. I forgot to write the problem down correctly. Alright. This way it just looks sort of nice at the end. Alright, and the derivative of 4y cubed is 12y squared. And then obviously 4 is a constant, but you have to remember, since it's a y, multiplied by dy dx. Alright, so the next step you do is sort of simplify. So it's going to be negative y, let me make it closer. I feel like this is going to be a big problem. Negative y plus, minus minus 3xy, because you're multiplying 3y by x, and minus 3xy. We're not forgetting about the dy dx. Minus 1 equals 12y squared dy dx. Just a small step that can go a long way. Next off, what you're trying to do is you are trying to isolate dy dx on one side of the equation. So what you're trying to do here is, as you can see, there's 12y squared dy dx, and then there's a 3xy dy dx. Add 3xy dy dx onto both sides. Alright, what this should give you is negative y cubed minus 1 equals 12y squared dy dx. Oh, jeez. Dx. Alright, plus 3xy dy dx. I am not writing my x's okay today. Alright. And after you do that, what I recommend you guys doing is maybe take a different color pencil or whatever, circle the dy dx. This way you can see that you can factor them. So going on, I'm going to continue over here. I know it's kind of messy. So currently we have negative y cubed minus 1 equals 12y squared dy dx. Now what you do, factor dy dx. Alright, and then you divide by this value. And right there, folks, is your answer to this problem. Dy dx equals negative y cubed minus 1 over 12x squared plus 3xy. That is a squared, by the way. I hope you guys learned something from this video. Just remember these steps and you should be good to go. Also remember to sort of factor at the end to solve for dy dx. I hope you guys learned something from this video. I apologize for my horrible handwriting. Pretty tough to write on the software. But I hope you guys can learn it and understand it from my verbal speaking. If you have any questions, please put them in the comments below. I will be answering them. Also, feel free to contact us with any questions. I'll answer those as well. Other than that, I hope you guys learned something, and thank you for listening.